To construct the 363-mile Erie Canal in the early 19th century, laborers had to dig through dense wilderness and blast through solid rock by hand. But the builders soon hit a chemical roadblock that threatened to halt the entire operation. The route required massive aqueducts and locks to raise and lower the boats, meaning engineers desperately needed a mortar capable of curing while completely submerged in water. Looking at this cross-section of a submerged brick wall, you can see the problem. Common quicklime mortar actively dissolves and washes away in the current. If the aqueducts and lock walls cannot hold together underwater, the canal cannot traverse rivers or overcome changes in elevation. Without a binder that could set in the wet, the link between the Great Lakes and the Atlantic was broken before it was ever finished. This map of New York shows the central region, where the canal's projected route cuts straight through the dense woods of a frontier settlement called Chittenango. While trying to fulfill a routine supply contract for common lime, local contractors dug up a strange, stubborn rock that refused to behave like typical limestone. Local scientist Dr. Barton took a sample of it to John B. Yates's trip hammer shop. He burned the rock, crushed it, rolled the raw paste into a ball, and dropped it in water to see what would happen overnight. By morning, that raw paste had cured rock solid. They had accidentally unearthed a massive deposit of hydraulic cement, known locally as water lime. That localized mineral discovery gave the Erie Canal the waterproof joints it needed to function and turned a muddy swamp outpost into an industrial hub. Looking at this photograph of the town's densely packed commercial buildings, you can see the rapid boomtown growth triggered when a lawyer named John B. Yates arrived in 1816 and recognized the monopoly value of that local limestone. Yates financed a direct side-cut channel connecting Chittenango's quarries to the Erie Canal. Along its banks, he constructed a plaster mill, a stone woolen factory, and a dry dock. With every phase owned internally, all profits funneled back to him. Yates had established a closed-loop system where he owned the raw limestone, the channel it traveled on, and the maintenance dry docks. In 1824, Yates pivoted from industrial expansion to a philanthropic experiment, purchasing a large commercial tavern in the center of town. He converted the building into the Yates Polytechnic Institute, prioritizing practical instruction over traditional theory. As we see in this diagram of the curriculum, the school paired classical studies like ancient languages and philology directly with practical agriculture, mathematics, and natural science. It operated as a manual labor school, requiring students to apply their academic studies to physical, real-world problems in the field and the workshop. Yates was using the profits dug out of the Chittenango quarries to fund a curriculum merging the expertise of the scholar with the utility of the laborer. One of the students who tested this new model was a young man named Garrett T. Thorne. Thorne focused his studies at the Institute on mathematics and civil engineering, disciplines that the school taught through hands-on application. Equipped with these specific technical skills, he pushed out of New York and settled in the raw frontier of Wisconsin. This curriculum provided a specific set of tools, the mathematical literacy required to plan a city, and the mechanical knowledge to physically construct it. In Wisconsin, Thorne put his education to work, building a legal practice and serving as a village president before winning a seat in the state Senate. During the Civil War, he volunteered for the Union Army and rose to the rank of lieutenant colonel, commanding the 29th Wisconsin Infantry. Thorne's career in law, governance, and the military was a direct extension of the technical and manual training he received in Chittenango. Over 50 years, Chittenango's output shifted. It began by supplying the raw mineral to build New York's infrastructure, and ended by training the leaders who would establish the civic systems of the Western Territories. The Erie Canal proved its value by moving thousands of tons of cargo, but the wealth it generated also funded the education of the individuals who would go on to govern and defend the expanding nation.